next part. Now coming to the next part, that is the concept of enable. So in multiplexers also, in multiplexer, when I had taught you about the starting of the first slide of the multiplexer, there in the general block diagram, there was one thing present, and that was the enable part. Enable thing was present over there. Okay, so enable thing was present over there. Fine. Now, what is this enable? Okay, so in the multiplexer, we have understood, we have studied that these multiplexers don't require the clock signals. So these don't require the clock signals. Fine. Now, instead of the clock signal, a enable pin or enable pin is there in the multiplexer. So which helps in generating the output based upon the change in the input. Fine. Now let us see what is the concept of the enable. Fine. So in a multiplexer, the enable input is basically an additional control signal. Yes. So this is basically a control signal that determines whether the multiplexer should operate or not, or means what we can say, it is a additional control signal, and it determines whether the multiplexer should operate or not. What it does, it determines whether the multiplexer should operate or not. Fine. It allows you to enable or disable the functionality of a multiplexer. What it does, it allows you to enable or disable the functionality of a multiplexer, which can be useful in various digital applications. Okay. So what it does, this basically allows you to enable or disable the functionality of a multiplexer. This basically allows you to enable or disable the functionality of the multiplexer. Fine. Now, if if you know that the inputs would be changing, but you don't want that the output should change on every input. Fine. So in that case, you can use this concept of the enable. So if the if your enable is in the on state, then depending upon the change in the input values, output would be changing, and if the enable is in the off state, then output won't be changing even if the input values are changing. Fine. Now the enable is sometimes denoted by en or e. Fine. Enable is sometimes denoted by en or e. There are two common types of enable inputs used in the multiplexer. Two common types of the enable inputs are used in the multiplexer. One is active high enable and the other is active low enable. One is the active high enable and the other is the active low enable. Fine. Now, what happens with the active high enable? What happens with the active high enable? Okay. So in this type of enable input, the multiplexer is active or enabled when the enable input is at a logic high level, usually denoted as 1 or 2. Fine. When ENI means enable high is high, the multiplexer functions normally, selecting one of the input lines based on the select lines and routing it to the output. Fine. When the enable high is low, the multiplexer is effectively turned off and it does not pass any data from the input to the output. Fine. So what happens in the active high enable input, active high enable multiplexer? So in the active high enable multiplexer, whenever the enable is 1 or true, then the multiplexer works, and whenever the enable is not 1 or true, the multiplexer doesn't work, or it doesn't route the input lines to the output lines. Fine. Now the other is active low enable. Now the other is the active low enable. Fine. Now the other concept is the active low enable. Okay. So what is active low enable? So in this type of the enable input, means in the active high, what the thing was happening, that in the active high enable, whenever the input is high, the multiplexer functions normally, selecting one of the input lines based on the select lines and routing it to the output. Fine. In the active low enable, what happens in the active low enables, the multiplexer is active or enabled when the enable input is at a logic low level. Fine. Now this active low works when the enable is 0 or false. Means when the enable is 0 or false or at the low level, then it is in the on state. And when for this particular the means this value is 1 or true, then it is in the off state. Fine. So what is the active low enable? In this type of the enable input, multiplexer is active or enabled when the enable input is at a logic low level. When enable low is low, the multiplexer functions as expected, selecting and passing data from one of the input lines to the outputs based on the select lines. When enable low is high, the multiplexer is disabled and this does not pass any data to the output. Fine. And this does not pass any data to the output. Fine. So this is the basically active high enable and the active low enable. This is basically the concept of the enable. Fine. Now next, coming to the some representations of the enable. Fine. So what basically you can say, there are basically two types of the enables. Okay, one is active high enable and the other is active low enable. Fine. There are basically two types of the enable. One is active high enable and the other is active low enable. Okay. Now uh, there would be some representation of these active high and the active low enables. Fine. So we would be understanding that those representation of the active high and the active low enables here. Fine. So first what I would be explaining, active high enable. Fine. First I would be explaining active high enable. Fine. Active high enable. Fine. Active high enable, and the right side of this I would be explaining active low enable. Fine. So what is what happens in the case of the active high enable? When En is 1, it is in the on state, and when En is 0, it is in the off state. Fine. When enable is 1, then it is in the on state, and when enable is 0, then it is in the off state. Fine. So the basic representation of this particular means active high enable would be, this is particularly a MUX. Fine. It would be in the on state when it is written in this format. Means something is written in this format, then it would be in the on state. Okay. Now if on this enable 0 is there, then it would be in the off state. Right. So this is the basic, or you can say the simple representation of the active high enable. So this is the basically the simple representation of the active high enable in case of the multiplexer. Fine. Now coming to the active low enables. Active low enable. Active low enable. Fine. So what happens in this case? If enable is 1 and enable is 0. Now if enable is 0, then it is on, and if enable is 1, it is off. Fine. So here can be various cases. 1, 2, 3. Fine. Now here it can be 0 and 0. So these all basically represents the on state of the active low enable. Okay, you can have a look over it. So these all basically represents the on state of the active low enables. Okay. So these all represent the on state of the active low enable. Fine. Now in which case these would be off. So I'm drawing that also. Now if one, okay, Fine. So in all these cases, it would be in offset. Means you can see that three representations I have taken. When the input 0 is applied, as it is the active low enable, so it would be in the on state, and in these three combinations only, when the input 1 is being applied, these would be in the off state. Fine. So this is the basic, or you can say some representations of the active low and the active high enables in active high enable in case of the multiplexer. Okay, so you can say this is some representation of the active high and active low enable in case of the multiplexers. Fine. You can have a look over it if you wish. You can just have a glance over it. Okay, so these are the basic representations of the active high enable and the active low enable. Now, coming to the next thing. Here I would be taking one example. Okay, here I would be taking one example. Okay, here I would be taking one example. So based on this example, means you would understand the concept of the enable. Fine. For the this particular thing, I am taking the example. Okay. Suppose this is the multiplexer. Okay. I0, I1, I2, I3, and enable. Fine. Here it is A, here it is A bar. Now here it is B, here it is A, and here this is written in this format. Now it's not an S1, not an S1. Fine. C and D are the select lines. C and D are the select lines. Fine. So what we can observe from here, that in this particular example, this is basically a 4x1 MUX, and the enable present over here is the active low enable. Enable present over here in this example is active low enable. Okay, so enable present over here in this example is active low enable. Okay, so the enable input is A. Okay, and okay, now in this case, when we have to write, okay, now one more thing, this is the output Y. Fine. Now when we have to write down the output equation Y, what we do basically in case of the 4x1 MUX, so Y is equals to S1 bar, general output equation is S1 bar, S0 bar, I0 plus S1 bar, S0 I1 plus S1 S0 bar I2 plus S1 S0 and I3. Now here in this case, what happens now here in this case? S1 is C, not is D. So we would be placing these values here in this case. Fine. So we would be placing these values over here in this case. Okay. Now putting these values in this particular equation, we would be getting Y is equals to something we would be getting, but here in this case enable is also present. Okay, here in this case enable is also present. So the final output that we would be getting is we would be multiplying this whole thing with the enable. Okay, so Y would be means this particular equation multiplied with the enable. Okay, now this is the active low, so we will be multiplying this whole function with the complement of it, as it is the active low enable. Okay, so here in this case, what would be the output? So the output would be Y is equals to this particular equation. Okay, that we are getting this particular equation, and the complement of the enable. So complement of it would be a bar. Fine. Now we can put the values and get our final answer. Okay. So final answer would be y is equals to S1 is C bar D bar. Fine. C bar D bar. I naught is A. I naught is A. Okay. I naught is A. Okay. Plus next is S1. Okay. D bar D A bar plus D D bar B plus plus C D and A. Fine. Now multiplying this whole equation with A complement. Now what would happen when this is multiplied with this? It will give the answer as D bar A into A complement plus C bar A complement into A complement plus C D bar B A complement plus C D A into A complement. Fine. So this is what we would be getting. Okay. Now I'm erasing this part. Plain U vector. Okay. So what we will be getting? We would be getting this would become 0. Fine. This would become 0. So finally, what we will be getting? C bar D A bar plus C D bar B A bar. Fine. This is the final expression that we would be getting. Okay. See, this is the final expression that we would be getting. C bar D A bar, C bar D A bar, C bar D A bar, and C D bar B A bar. Fine. So this is the final expression that we would be getting. So this would be our final answer of this particular example. Okay. So I guess you might have understood it till now. Okay. Now coming to the